Okay, so let's look now at how to interpret function notation when you look at a graph instead of a table. The process is going to be the same, just what we're looking at is going to be slightly different. So as you will recall from just a few minutes ago, the number inside the parentheses is your x value, and the function value we're looking for is the y value. So as we look at number 9 and we look at part A, the question is, what is the function value if x is -6? When we look at the graph, we have to remember which is our x value and which is our y value. The x-axis goes left and right. So that means we want to find where the x value is -6. We will go -6 on the x-axis, which puts us here. Now that's not the function value. The function value is where does the graph cross where x is -6. So in this case, we're going to look down. The point where f is -6 is down here at a y value of -4. Now realize on the graph, the negatives are kind of covered up with the tick marks, but the fact that we went down instead of up further emphasizes that we're talking about negative. So the point of the graph that is at an x value of -6 has a y value at -4. If we want to do this again where the function value is 1, we do have to read the scale on the graph because there's not an x value that's marked as 1. That's just because it would get very crowded and difficult to read if I marked every tick mark with the actual value. So sometimes you're going to have to use the scale to figure out how to read the graph. In this case, the x value is +1 here. This time I have to look up to find where the graph actually crosses f of 1, and it crosses f of 1 at a y value of +4. You should pause the recording and maybe try the next two on your own. Function value where x is 8 is here. I look up, that means my value is going to be positive, and I have to look up all the way to a y value of 8. The last one, which is kind of tricky, first of all, it's asking me for the value where the x value is -7, which is here, again, on a line that isn't specifically marked. More than that, the place where it crosses is here, even though the graph didn't make one of these points. I could still see where it crossed, and it crossed down there at -6. So you have to be able to read the graph, not just look at the dots. And sometimes you may have to estimate where the line crosses if it doesn't cross exactly on crosshairs of tick marks. Now the last two, just like in the table, these are kind of backwards. If the x value is in the parentheses and the number at the end is the y value, we're going to look where y is -4 and figure out what x value that has. For a y value of -4, that means we're on the y-axis and we go down to -4. And we look left or right to find the x value. In this case, we go to the left, and we go to the left where x is -6. And where do we cross the x-axis when y is 0. Y is 0 is the x-axis. So if we look across the x-axis, the place where it crosses is at -1. Now notice on these, we do have to specify that x is -1. So, let me scroll up here. There's just a couple of things different with this graph. For the most part, it's the same. How we read the function notation is definitely the same. If I want to find the y value where f is -6, there is no difference here. Number inside the parentheses means I'm looking on the x-axis. I go back to -6. I find where it crosses the y. This one is just a tad more difficult because, again, I didn't put a dot on all of these points, so you're just going to have to read the graph. -6 crosses here, which is also a y value of -6. +1 would be here. I would go down 1, which indicates a negative on the y-axis. And if x is 0, that means we're staying right here, and y is also 0. Now that can be a little confusing sometimes when x is 0 or y is 0, so it's worth taking an extra little beat to think about that. Now here's where things are really kind of different. When I do the ones that are, I'm going to tell you the y value and you have to find the x value. The y value here is -4. A y of -4 is here. The question is, what is my value of x? Well, there's two of them. Because if I stay here where y is -4, I have a point here and I have a point here. So I'm going to have two answers to what x values do I have if y is -4. X can either be, in this case, -4. X can also be, if I look over here, +4. In this example, we have +4 and -4 as our two potential values. That doesn't have to keep that same pattern. This particular graph is symmetric on the y-axis, so they are just the same number, one positive, one negative. They don't have to be the same number. They don't have to be one positive and one negative. So don't make rules that don't exist. You can have two possible x values that are both positive and two totally different numbers, like x is 1 and x is 15. You can have two negative ones. So don't read too much into the fact that it's a positive and negative of the same number here. I know it's easy to do that when you only have one example. So that's 9 and 10. This is how you find your function values from a graph. Now, in the last three problems, we're going to learn how to make a graph. So I'll see you back here again in a few minutes.